So how should we go about mitigating the effect of climate change? From a physical science perspective, limiting human-induced global warming to a specific level requires limiting cumulative CO2 emissions, reaching at least net zero CO2 emissions, along with strong reductions in other greenhouse gases. Let's suppose that we want to limit global warming to 2 degrees Celsius over pre-industrial levels. To achieve such a goal without negative CO2 emissions, we have to limit the cumulative amount of carbon emitted since the beginning of the Industrial Revolution to 1 trillion tonnes. This amounts to around 3.7 trillion tonnes of carbon dioxide. 1 trillion tonnes of carbon emitted would likely limit us to 2 degrees Celsius rise in temperature. Such a limit has been argued would avoid the worst impacts of climate change. However, recent projections have suggested that a 1.5 degrees Celsius limit may be required. This figure shows the roughly linear relationship between temperature rise and total amount of carbon emitted. Only the very low and low greenhouse gas emission scenarios avoid a total carbon emission of 1 trillion tonnes being exceeded by 2050. The world has enough proven fossil fuel reserves to go well beyond this carbon budget of 1 trillion tonnes. To keep under this budget, we need to limit our future carbon consumption to about 400 billion tonnes. At our current pace of consumption, we will exceed the 1 trillion tonne budget by around 2045. This does beg the question as to how we should slice up this budget. Divvying up the carbon on the basis of GDP would leave little for developing countries to use for their growing economies, but would give more to developed countries which are better able to create value from burning carbon. Doing it on the basis of population would give developing countries a chance to develop with fossil fuels, but it leaves little time for carbon-intensive economies to switch to renewable energy sources. The magnitude of the problem of mitigating climate change seems beyond our capabilities. Early debate saw the problem as needing a silver bullet, a single optimum technology that could be deployed to get us from today's carbon glutinous energy system to a carbon-free energy system of the future. Stephen Pacala and Robert Socolow argued that we should be using buckshot rather than a bullet. That is, instead of finding any one single low-carbon technology to deploy, we should be taking a more diversified approach. In this approach, we can think of any single technology that would lower carbon emissions as an emissions stabilization wedge, which, if deployed, could by itself avoid a modest 1 billion tonnes of carbon emissions per year. We currently emit about 10 billion tonnes of carbon per year. While no single 1 billion tonne wedge would be adequate to avoid dangerous climate change, a combination of stabilization wedges could be. This figure imagines the need for 9 such wedges to stabilize emissions. How could this be achieved? Well, Pacala and Socolow recognize that the technology already exists. Such technology wedges could be achieved through efficiency. For example, double the fuel efficiency of 2 billion cars from 30 to 60 miles per gallon. Decrease the number of car miles travelled by half. Use best efficiency practices in all residential and commercial buildings. Or produce current coal-based electricity with twice today's efficiency. It could be done through fuel switching. For example, replace 1,400 coal electric plants with natural gas-powered plants. It could be achieved through carbon capture and storage. For example, capture and store emissions from 800 coal electric plants. Produce hydrogen from coal at 6 times today's rate and store the captured carbon. Or capture carbon from 180 coal to synth fuel plants and store the captured CO2. Through nuclear, for example, by adding double the current global nuclear capacity to replace coal-based electricity. Through wind, For example, by increasing wind electricity capacity by 10 times relative to today, for a total of 2 million large windmills. Through solar, for example, by installing 100 times the current capacity of solar electricity, or by using 40,000 square kilometres of solar panels to produce hydrogen for fuel cell cars. Through biomass fuels, for example, by increasing ethanol production 12 times, by creating biomass plantations with area equal to 1/6 of world cropland. And through natural sinks, for example, by eliminating tropical deforestation or adopting conservation tillage in all agricultural soils worldwide. Although no single strategy will suffice, a combination of the technological strategies described here will build the stabilization required. However, further wedges will be required to bring the world down to no carbon emissions. In addition to the technology wedges, we may need behavioural wedges, such as cutting driving in half, cutting projected meat consumption by a third, or cutting projected miles flown by a third. Breaking the problem down into manageable chunks does seem to provide a vision of the possible. Thanks for listening.